So this problem showed up on the August SAT. It's about two similar cylinders who are given their volumes. We are given the volume of cylinder A, as well as the volume of cylinder B. We're also given the radius of cylinder A, which is 9 centimeters, and we're supposed to find the surface area difference between the surface areas of these two cylinders. So the key to realize here is that we kind of have to set up a proportion here to find the scale factors between these two cylinders. And then once we know the scale factor between these two cylinders, we can find the surface area that way and subtract them. So what am I talking about? So if we set up a proportion between cylinder B and cylinder A, since we know that cylinder B is the greater, is a cylinder with a larger volume, we know that it's gonna have either a larger radius or a larger height. So let's find a proportion between these two cylinders. So we can set up 162,000 pi over 1296 pi and solve this proportion. We get that it's 125. But we know that this is a proportion between these volumes. So it gives us the scale factor for the volumes between these two cylinders, which is to say that it's not the scale factor in the first dimension. Volume is a three-dimensional concept. So we are finding the scale in 3 dimensions here. But we're supposed to find the surface areas for these cylinders. And we know that surface area is a 2-dimensional concept. So what we can do here is that we can take the cube root of 125, which we know that it's 5, and square the scale factor again to get 25. So what does 25 mean here? 25 is basically the scale factor in the second dimension. If we cube 125, we are getting 5, which is the scale factor in the first dimension, but that's not gonna help us here. 25 will help us more here because it gives us the scale factor in the second dimension. And if we find the surface area of cylinder A, we can pretty much multiply by 25 to get the surface area for cylinder B. And that's going to help us more here because we are supposed to find the difference between the two surface areas. So once we now have the scale factor in the second dimension, we can work backwards here using the information we have in the problem to solve for the height of cylinder A. So we know that the volume of cylinder A is 1296 pi, and the volume formula is pi radius. We know that the radius is 9, so we can square the radius, and we are supposed to find height here. So dividing by pi 81, we get height is 16. So now that we know the height, we can solve for the surface area of cylinder A with the formula that we're given. So the surface area of cylinder A, we know that it's 2 times pi radius squared plus 2 pi radius times height. So after solving this and collecting like terms, we get 450 pi. So this is the surface area of cylinder A, but we are supposed to also find the surface area of cylinder B, so that's where the scale factor comes in handy here. Since we know that surface area is a 2-dimensional concept, we can multiply 450 pi times 25 to get, Desmos is efficient here, so 450 times 25 is 11,250. So this is the surface area of cylinder B. So now that we know the surface area of cylinder B, we can find the difference between these two surface areas. Since J is the bigger value, we can subtract 11,250 pi minus 450 pi. And after subtracting these two values, we get 10,800 pi. So 11,250 is J in this case, and 450 is K. So if we want to find the difference between them, J minus K, we get the value 10,800. So J minus K is 10,800. So this is the fastest way to solve this problem.